Ranak everybody, we continue talking about difference in statement and how it influences the result, and today we talk about Bolt Pretension. As you see in our model, we have two bolts, and in most cases those bolts present here not in general case but with pretension. So we choose first our simulation, our first task with 3 fixation on all faces of base. We have 10,000 of newtons here, and this is result 0.57 of millimeters displacement and 243 megapascals here, and we can see stresses here. It's all blue, so it's less than 30 megapascals. Okay, let's do some changes. So we add a bolt pretension. We add bolt pretension to those objects, and we create big pretension force, so it's also 10,000 of newtons on each bolt, on one and second bolt. Okay, we have deformation, and it's the same. It's 0.57 millimeters of displacement, and it has almost the same stress distribution picture, but we can see some difference here and here. We see that some plates have stresses more than 30 megapascals. So our bolt pretension in linear statement with linear contact doesn't give anything new to our model. Yep, it give higher stress here on this place, but not so big. And yes, its stress depends on level of bolt pretension, but in most cases we have the same result. Okay, let's open our task, our statement with frictional contact. And if we take a look here, we doesn't have bolt pretension here, and we see some gaps here. If we create something like 5 times of auto scale, we will see something like that. We see that it's not touched. We see that we have gaps in any place here. Let's return to our first task. Let's do 5 times scale factor, and we see that we doesn't have gap here. Any gap here we doesn't have in any place in reason of bonded contact. Okay, we understand that. So let's add a bolt pretension, and we add bolt pretension. We have frictional contact. So what result do we will have? And we have 0.64 millimeters. Let's return to this one without bolt pretension. Fix 66 and 64. So adding our bolt pretension, do deformation of this part smaller. Let's take a look not into a true scale but into 5 times deformation. We see that we doesn't have gap here. We see that we doesn't have gap here. We see that we have gap here between those two balls and gap here. And if we take a look here, we see that we have some gaps, but not on all faces, on some faces. So it means that when we create bolt pretension, it became something between bonded contact and frictional without bonded. Which place will be between in this range, which we obtain in this range, depend on the number of bolts, of bolt pretension, and so on. Also, we need to understand that we can do simulation with bolt pretension in several ways. For example, this result obtained in one step. What does it mean? We have only one step. We have force in one step. We have bolt pretension in one step, and so on. And the second result which we have is result which we obtain in two steps. On the first step, we create bolt pretension, so we create pretension on our bolts without force here, and on second stage we apply force. And we obtain a result which are very close but not identical. On a deformation we doesn't see difference. On a stress we see some difference, because stress are more accurate result. It's more sensitive. So why do we have difference? We have linear material model and it's not matter, but we have nonlinear solution. Contacts give to us nonlinearities, and we came through two different ways. On one way, on the first way, we change bolt pretension, in this way, and in this way, in this step, we apply our force. On the second way, we create bolt pretension and only then we create a force. So we came with two different ways. It can be very similar, but it's a two different way. Okay. let's do some additional changing. Let's change level of our pretension preload from 10,000 to, for example, 1,000, only 1,000. We do it on our first approach with linear bonded connection here, with linear bonded contact. And we doesn't see any difference, any big difference, even in stress. Yep, we see some difference in place of blue color here, but it's not very big. In behavior of this construction, we doesn't see any difference. Let's return to our task with non-linear contact. This is our solution with 10,000. And this is our solution with 1,000. This is Bolt Pretension, and this is 1,000. And this is result in the same scale. This is result of deformation, and if we create true scale, we will see something like that. So, why it is? The reason of this are not fully physical, because if we create small pretension on real bolts, we will not obtain those differences. Even if we create zero preload on our bolts in real life, we will not obtain those results. So why we obtain those preload problem here? We have 10,000 here, we have 1,000 here, and 1,000 here. And if you will look on a scale, you will see those steps here. And if we think, we will understand that Ansys and many other products create bolt pretension in those type. They slice our bolts, delete some materials, do some gap, and add a spring here, or add a force here. And depending on way we create this preload, this bolt pretension, we can obtain very different result. And in some way, in some case, with small force that not compensate other force, we can obtain a result like this. So be careful. Be careful and think what you are doing. Okay, and the last thing that I want to show, it's a comparison. We can see how it works here. See? Comparison of result with this behavior and with this behavior. If we doesn't have gap here and we doesn't have gap here and here, why do we have such big difference on the stresses on our bolts? And reason are very simple. We doesn't have here gap in reason that work only this bolt here and this bolt here. So all loads which try to open this gap came to this bolt and to this bolt. All forces. In reason that we doesn't have glued here anything. In reason that we glued face here, all face here, between base and those crank. In reason that we glued our bolts with base and crank, all our forces are distributed to all this face, to all this face, and so on. So that's why we doesn't see that our bolt work much more. And on this way we see it that all our bolts are work much bigger. If we compare this result with Bolt Pretension and this result with contacts and no Bolt Pretension, we will understand that here these two bolts also work with all forces like here. But here we have zero additional force. And here we have 10,000 of newtons of additional force. And you need to understand that we, when create our Bolt Pretension, obtain force not only from this one, but additionally from this place which want to interfere. In reason that the bolts are preloaded and compress those two parts and try to interfere it. So, yep, Bolt Pretension are very good things that help you to create more adequate result. But please be careful and please understand what physical process you will have and how mathematically it described with numerical method such as finite element method. If you will not understand, better not to use additional option. Better to simplify your process. Thanks. Hope it will helpful for you.